Hello everyone, this is Professor Iris Miano giving you day 20 lecture in Math 50 pre-statistics just on one section, section 6.2, determining the four characteristics of an association. So we're going to be looking at scatter plots, which we just recently covered in day 19 lecture video, and we're going to be looking at trends and deciding if they are linear, non-linear, or having no association at all. And we're also going to be talking about calculatable values that show the type and strength of these linear associations. If an association is nonlinear, it's going to go beyond the scope of this course. Okay, so let's add some notes and let's talk about what it means to be a linear association. Well, it's all in the name. Linear associations are lines. So lines, no curves, are going to be associated with the type of association, where some associations can follow a curve. So it'll be either it'll be a curve basically that the data will fit into, and no association is basically the scatter plot looking more or less like a blob, like there's no trend either way. As you scan from left to right, there's just a bunch of dots all just kind of randomly placed and more or less evenly distributed throughout the space associated with the coordinate plane in which it's plotted. Now, looking at these figures that are given as examples, we see linear associations for these first two. These are linear. And you see that they follow a line. Now, notice that the blue dots here in either of these first two figures are not super tight and lie exactly on this red line of best fit. In fact, for this rightmost top figure, you see that very few of the dots are actually on the line, but they are trending according to the line. So here, for the first two figures, we have a linear association in which it's positive here, because what we would perceive to be the line of best fit has a positive slope, where here this linear association has a negative trend, because its line of best fit has a negative slope. Okay, here are some other associations, the non-linear type, and you can see that they follow curves. So this is non-linear. This one being exponential. Not that you need to know this. This is an exponential association. This is a parabolic association. But don't worry about those things too much. We're not going to get into detail on that. And here are the, what's the phrase that we use for this? No association. These are your blobs right here. No association. So yeah, basically in this section, we're just going to be looking at a lot of different data sets that are represented by scatter plots and determining what, if any, association could be categorized by the scatter plot of the data. So these are each looking very blobby, I would say. There's no way that I could draw a line of best fit and argue that it, matches the trend of the data. Okay, so these are blobs. I'll just go ahead and call them blobs here. That's not a technical term. That's just the way that I describe what the scatter plot looks like for data that seems to have no association. Okay, so there are calculations that can be performed in order to determine the strength and type of association, linear relation, that two quantitative variables have, and that's going to be your R coefficient. So I want you to write strength and type in those first two blanks. And then there are lots of different features of the R linear correlation coefficient that I want to address with you guys. So the values of R are going to range between -1 and 1, including those endpoints. The values of R are between -1 and 1, inclusive. If R is positive, then the variables are positively associated. If R is negative, you can probably guess what I'm going to write in the next blank, then the variables are negatively associated. If R is 0, or I'll say 0, then there is no linear association. That's when you have a blob kind of a thing. Or a curve. Sorry, I don't mean to make it sound like it's just going to be a blob. If the R value is 0 or very close to 0, you could certainly have a curve being the line of best fit for your data. Next bullet, it says the larger the value of R inside of some absolute value bars, so the absolute value of R, then the stronger the linear association will be. So let's say that you have an R value of -0.99999, right? Well, the absolute value of that would be 0.99999, and that's a very high number in regard to you know, all of the numbers that are possible for R within the range of values that it can take on between -1 and 1. So we would say in that case it would have a strong negative association. Okay? Whew. All right, here we go. 2 more bullets to fill out. Now, R can take on a value of exactly 1. So if R equals 1, then the points lie exactly on a line and the association is positive. And if R equals -1, same thing, only you know, it'll lie exactly on a line and the association is negative. So let's look at some figures that show us what this will look like. So the first two that you see on the bottom of the second page is R values of 1 and -1 respectively. So you notice that the points lie exactly on a line. Whether it's this one or that one over here, a positive association with the left figure, and then we have a negative association with the right figure. Okay, now, if the points spread out a little bit away from what we would perceive to be a good line of best fit, like for instance, I'm going to just in red draw a very rough line of best fit for each of these. I would say something like this would be appropriate line of best fit for that first one, and it's definitely that line has a positive slope to it, and the data points are pretty close to that line of best fit, so the R value is going to be high there, relatively high. And now, but you could have the same thing going on where it's a relatively you know, tight fit, not on the line, you know, by any means, but it's pretty close. And in that case, because the slope of the line of best fit would be negative, the association would be negative, and the R value will be negative, but the absolute value of it will still be relatively high or close to 1. Okay. Next, we will have instances in which there still is a pretty clear indication of the association, but the data is a bit more scattered away from the line of best fit, which would be about right there for your left figure there, positive association, but data is scattered, so the R value, the absolute value of the R value goes down to 0.6 or negative 0.6 if your trending line is facing downward. Okay, cool. And now here, lastly, we have two instances in which we would have an R value of 0, and that would be associated with your blobs, right, which is what we have here, or your non-linear associations. Okay, great. Moving on. Now let's have an example. Let's determine whether there is a linear association, a nonlinear association, or no association at all. And then if it is linear, we're going to, or actually, no matter what, we'll estimate the linear correlation coefficient R, okay? So let's start with E, right? This first one right here. Now, if I am trying to figure out what would be like a good estimate for the line of best fit, it looked like something like that. And I would say that the data, while not completely on the line, is pretty close to it. And it's the line of best fit is sloping downward, so it's negative. So I would say that this is a good example of R equaling negative 0.9. For the figure in A, look at that tight fit. On the line of best fit would be, you know, like that, pretty much. Sorry. Please excuse the bumpiness of my line of best fit. That's the best I can do with this stylus. But it's positive, and all of the data points pretty much lie on the line, so I would call that an R of 1, okay? And then for D, I would say there's definitely an association, and it's positive. Like I could draw a line of best fit that I could argue fits the data, something like that. But, you know, it's pretty widely scattered around that line. The trend is still there, but it's not super strong. And since it's positive, I would call that an R of 0.6. And then lastly, for this last figure that doesn't have a letter underneath it, I would say that that's a blob. And blobs have an R of 0. Okay, so hopefully that feels good and makes sense. Let me know if you have any questions in lecture about these guys right here. Super short lecture video, super short class period are going to be associated with this. However, it could be a good opportunity for you guys to ask questions about some older stuff, or maybe even start reviewing for exam 4, which is coming up. It's going to be the week of Thanksgiving. For us. Yeah. Okay, great. That is it for today. I am like flabbergasted by how short this lecture video is, but there you go. Enjoy a short video. See you soon.